Hi everybody. In this screencast I'm going to talk about formulas and inequalities. So this is from like the second half of lesson 2.4, and then that's the formulas part, and then it'll go into lesson 2.5, which is inequalities. Since I have a tendency to go on and on, I'd recommend that you skip over the parts you already know. Okay, so watch. Actually, and another strategy would be to stop it when I give a problem. I show a problem, stop it, then see if you can work out the problem first on paper, and then push go and listen to what I have to say about it, and see if what you did is the same as what I did. All right, and you can always rewind anything that you find difficult, so you can watch it again. All right, so enjoy. So, formulas. We've been dealing with formulas for a long time. Most of us are familiar with this one, A equals length times width. I better make this pen fatter. If I know what length is, say the length was 3 and the width was 5, then we could figure out what the area was, A. This is the area of a rectangle. So the area would equal 3 times 5, or 15. Area equals 15. And if, so let's say that the area equaled 15, which we just figured out, but let's say we didn't know. So we were given A equals 15 and L equals 3. Then we could just plug this information in. 15 for A, 3 for L, and then we put the W, and we'll figure out what the width is, the W. So we have to use our equation solving skills. We divide both sides by 3. That cancels out, and we get W equals 5. Okay. So these are easy to do, but let me do a more complicated one. Let's work with the area of a trapezoid. The area of a trapezoid is A equals 1/2 h, being the height, times 2 bases, A plus B. Or it could be considered h equals 1/2 of A plus B. Let's write it that way, h times 1/2 A plus B. Okay, so a trapezoid looks something like this. The thing about a trapezoid is that the two bases, let's say that this is A and this is B, the two bases are parallel to each other, but they're not the same. Usually not the same. They're not the same size. It's just they're not the same size. So there's almost like there's two triangles on either end, and they're two different size triangles usually, but they could be the same size. It doesn't matter. But all we need to know is we need to know the length of the two bases and the height, which is h. From the bottom base to the top base. The shortest height from the top to the bottom. And we can figure it out. So the hard part about this is you're going to have to know what's the base and what's the height, so you can plug it in. Otherwise, the plugging in part, that's the easy part of this. So let's say we had one. I'm going to make this one. Okay, pretend that those two bases are parallel. And let's say the B was 4 and the A was 2, and let's say the height was also 2. Okay, let's call them inches. 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 Okay, so then we have A equals, and we'll stick in something for the H. So I don't know. Let's use this top let's use this top one. Okay, so we'll go 1/2 times, and we'll stick in our h, which is 2, times a, which is 2, plus b, which is 4. Okay, so now we just have to calculate it, and we're done. 1/2 times 2 is 1, so 1 times 2 plus 4, or 2 plus 4 is 6, so the area equals 6. But we have to ask the question, well, the area is 6. 6 what? Whoops. Area equals 6. But we were dealing with inches, so it's got to be the area equals 6 inches squared. Okay, so we said, well, the A was 2, H is 2, and B is 4. But what if we didn't have one of these? What if we didn't have the A? So let's scratch that out. Okay, we didn't have the A, but we knew that we had the, instead we had the area, which is 6 inches squared, and this is inches, and this is inches. Okay, well, we could take our formula, A equals 1/2 H times A plus B. Okay, and then we're going to be looking for B. No, we're going to be looking for A. Okay. Yeah, we're going to look for A. So, question mark. A is what? What does A equal? So we can figure that out. Of course, we'll just plug everything in. We'll put in a 6 for A. Got our 1/2 times H, and our H is 2. And then we don't know what A is, but A plus B, we know what B is. We'll stick in a 4 there. Okay, so we can solve this. We've been solving equations. So first we simplify both sides. This side is already done. This side, 1/2 times 2 is 1, so I can just put A plus 4. And I can subtract 4, or add a negative 4 to both sides. Right? So A equals 2, because those cancel each other out. See, so you can work in either direction. Alright, so the second half of this formula thing is solving for a variable. So let's say we had that same formula. We've got area equals 1/2 the height times A plus B. Alright, so we're going to solve for a variable here. Let's say we were going to solve for H. It would be written like this, for H. And that means instead of having an A equals 1/2 H times A plus B, we're going to have H equals something. And we're going to end up having all of these things in our finished equation. We're even even have the 2, maybe not the 1/2. But it's not going to be looking like this. It's going to look differently, right? So let's do that. Let's solve for H. I don't know what I put there before, but let's solve for H. That's what it'll look like. Okay, so we'll solve for this guy. All right, so I think in terms of, well, what do I have to get rid of? Well, I've got to get rid of this, and I've got to get rid of this, so it's H equals, and I can't just erase them, right? So I've got to divide them out or multiply them by the reciprocal. So the 1/2 I can multiply by the reciprocal, which is 2, or 2 over 1. So I'll multiply the A by 2, and I'll multiply this one by 2 over 1, times 1 over 2. And then that's times H times A plus B. Okay, I'll do that first. So this becomes 1. That's times h times a plus b. Just copy everything down, everything that you don't touch. And then we've got 2a here. 2a. Okay, so now the thing I got to get rid of is this a plus b. Well, why can't I just divide all of a plus b out at the same time? Right? I'm going to do that. I'll say let's put a plus b underneath here. A plus b. Just to make it look the same, I'll put a parenthesis around it. But I'll just do the same thing to this side. A plus b. Okay, so I've done that. This and this. A plus b divided by a plus b equals 1. So I've got 1 times h times 1, which is what? It's just h. So h equals 2a over a plus b. Alright, but what if I want to solve this for b? For b. It's like, uh-oh, can't do it, because b's tucked away inside this parentheses. How am I going to possibly do that? Well, we can use the same strategies. Let's just think about, well, what do we have to get rid of first? Well, we can't get that a out of the way first. That's the hard thing. It's tucked away inside the parentheses. But what we can get out of the way is we can get rid of the 1/2 and we can get rid of the h. So let's do that. Now we can do them both at the same time, or we can do them one at a time. Okay, so let's just do them one at a time, not to make it too complicated for us. Let's go let's do 1/2 first. So we'll go 2 over 1 times 1/2, and that's going to be h times a plus b, and that's going to equal 2 times a. Remember from last time. Okay, so we get 2a equals h, because 2 over 1 times 1 over 2 equals 1, which is, 1 times h is h, so we'll just leave it as h. H times a plus b. Now you think, oh no, I gotta get rid of that a. Well, we will eventually. Let's just take things one at a time. Okay, so now to get rid of the h, let's just divide by h. Okay, so divide by h, but we gotta do it to both sides. Okay, there goes the h. So now we have 2a divided by h equals a plus b. Now I can let go of the parentheses because I don't need them. I just use them to separate things. Alright, so I'm doing this for b, so I want to keep my b, so I get rid of the a. How do I do that? Add a negative a or subtract a. Okay, I'm going to add a negative a on this side. Okay, which I could put, actually I could put it right here, subtract a, but I don't need enough room. Alright, so what do I get? Well, I'm subtracting the a's, so these two a's go away, right? So I have b, right? And then over here, I'm going to just rearrange this again. So I'll put the 2a over h minus a. Can I do that? Of course. Let's do a simpler case, though, just for laughs. We've got a equals LW. Area equals length times width. That's the area of a rectangle. Okay? So length, width, areas, all those boxes in between there, right? Depending on how big it is. Okay, but we don't have numbers. We don't know how long it is, how wide it is, or what the area is. We just want to do it for a letter. So let's solve it for L. Okay, so what do we want to get rid of? We want to get rid of the W, and we'll be all set. Right? So we've got A equals LW divided by W divided by W. L equals A over W. Say you had somebody who, you had a bunch of areas and widths and you wanted to know the lengths of them, and you gave that job to somebody else. You could solve it for it and say, okay, take all these areas and divide by W. Okay? Alright, so now you're wondering about circles, right? Alright, we'll do a little thing on circles, and then we're going to go into the inequalities. Okay, let me tell you about the circle. Okay, the circle has some features. The length around it, or the perimeter of a circle, is called the circumference. I had trouble writing that. Alright, okay, there's a center of a circle, and then a line that goes from one side through the center of the circle to the other side, that's called the diameter, signified usually by D. Diameter. Okay, and then the part that just goes from the center to the outside is called the radius. Now the circumference formula is 2 pi r. Sometimes it's called pi d, and that's because this 2r equals d. See, so pi d is the same thing as 2 pi r. Okay, because as you know, the commutative property 2 times pi times r is the same as pi times 2r, and 2r is the same as d. See, so those are the same. Okay, but usually you're going to see it, with us, you're going to see 2 pi r. And then there's the area of the circle, which is pi r squared. And it makes sense that something is squared, because areas come in squares. I mean, we will describe it. If it was in inches, it'd be square inches. If you wanted the area of the circle in centimeters, it'd be square centimeters, centimeters squared. Okay, so you need to be able to identify these three things. Okay, let's say that r is 3, and we want to know what the circumference is, right? And you're going to be told that for pi, we'll use the number 3.14, which is an approximation, right? The only exact pi is this symbol, pi, which is a Greek letter called pi. And they use that symbol, that's exactly pi. But if we want to use a number, substitute it in, it's going to be approximation. It's going to be as close as is necessary. So we'll use this one, 3.14. It's to the 100th place. But, you know, if we wanted to be super accurate, we could go to more places. But we don't need to be any more accurate than 3.14 for most things we do. For most measurements we would use in building something. So if we want to find the circumference, and our circumference is 2 pi r, well, our r is 3. There's our r. That's all we need to know because we already have the 3.14. So to find our circumference, we multiply 2 times 3.14 times our r, which is 3. Okay, now I can multiply these in any order, so 3 times 2 is 6, so I've got 6 times 3.14. So 6 times 3.14, if I look on my calculator, or if I figure it out longhand, I get 18.84. But what are we talking about? 3 what? Well, it doesn't say here. So, but what if it was 3 centimeters? Let's see. Centimeters. Then each of this 3 would have been 3 centimeters, and multiplying this all out, we would have gotten 18.84 centimeters, right? If we're talking about the circumference, that's the length. And we said centimeters squared. That would be wrong. Okay, so now what if we were trying to find the area of this? Well, area equals pi r squared. So we substitute that 3 into r squared. So we have our a equals pi, which is 3.14, according to us, times 3 squared. And order of operations tells us that we figure out the exponent first. So 3 squared, or 3 to the second power, is 9. So we've got 9 times 3.14. And that equals 28.26 what? Well, centimeters squared, because now we're talking about area. It'd be squares. And that's our answer. One more thing. There's dealing with slope-intercept form. How to put a formula or an equation, actually, it's an equation, into slope-intercept form. This is the standard equation form for a line. Standard equation form is ax plus by equals c. See, so in this one, the 9 is the c, the 3 is the b, and the 4 is the a. So a, b, and c they're just all numbers or constants. And to put it into slope-intercept form, we would want it all in the y equals form. So it's going to look different. And I'm going to show you how to do that. So what we want to do here is we want to get everything in terms of y. To do that, we've got to look at what we got to get rid of. So we've got to get rid of this term, first of all, and then the 3. Well, we'll start with the 4x. So we go 4x minus 4x plus 3y equals 9 minus 4x. Okay, so 4x minus 4x is 0, so we just have 3y equals 9 minus 4x. Okay, so now we got to get rid of the 3, so we just divide by 3, divide by 3. Okay, 3 into 3 is 1, so we end up with y, that's good. Okay, now we have to divide this 3 into both the 9 and the negative 4x. So 3 into 9 is 3, and 3 into 4, negative 4, becomes a decimal, so we don't want that, so we'll just leave it as a fraction. We'll leave it as a negative 4/3 x. Now, let me just bring in a little arrow over here. What we'll do when we get into chapter 3 is we're going to switch the 3 and the negative 4/3 x around. So we'll just go do this. We'll go y equals negative 4/3 x plus 3. We just switch their places. You know, we can do that because of the commutative property. And that will do something for us. That'll give us the slope, which is this, and the y-intercept, which is that, which we'll find very handy later on. But the first thing we have to be able to do is do this. So let's do one more.